Hello everyone. For today's problem, we're going to look at a proportions problem. Proportions. Whoa. Let's fix that first. Okay. So it's a proportions problem, and let's just write down whatever they have given to us in the question. The reduction. Okay, so the reduction, the change. Okay, the reduction in an engine's speed is directly proportional to the square root of the number of wagons. Okay. So they've already given us the formula. So delta V, okay, which is a change in engine speed, is equal to, let's introduce a constant of proportionality under, square root of the number of wagons. Perfect. The max speed of this train is 42. Max speed equals to 42 kilometers per hour. With 9 wagons, the speed drops to 24 kilometers per hour. So this is a case, this is a situation where we have 9 wagons and its speed is now 24 kilometers per hour, right? 24 kilometers per hour. From here, we can kind of find out the delta V, which is original speed, the original speed minus the current speed. Original speed was 24 and the current speed is, original speed was 42 and current speed is 24. If you subtract these two, you're gonna get 18. So delta V, the reduction in speed, is 18. And we have a formula over here, delta V. And W, the number of wagons, is 9. So we can kind of plug in the numbers and find our constant of proportionality. So substituting the values, we get, just double checking, delta V equals K times under root W. So delta V, that's 18, equals K times square root of 9. Changing up the values, we can get 18 divided by 3, which is equals to 6. So 6 is the value of K for us. Great. Let's proceed with the problem. Find the maximum number of wagons the engine can actually pull. So now we have to think about the problem a little logically. So we have the, the track, we have our beautiful train, okay, and we have the wagons. As we add more wagons, the speed decreases, which means that the delta V is going to increase. And the question says the maximum number of wagons the engine can actually pull. So even if the train is moving at, say, 1 kilometer per hour, it's still moving, right? Technically, it's still moving, and 1 kilometer is, 1 kilometer per hour is very close to like 0.0001 kilometer per hour. Okay, forget about the 1 kilometer per hour. Even this one, 0.0001 kilometer per hour, is actually some sort of movement. So when will we achieve this situation? When will the train move so slow that its delta V becomes equal to its original speed, right? If original speed is 42, when will the change in speed become 42 as well? Because if this situation happens, it means that the train is moving super slow. That's what we want to find out. And I think we've already kind of figured it out. So let's just write it down mathematically. We want delta V to be 42. And we know that our original speed, well, we want our current speed to be 0 kilometers per hour. Okay. And we know that our original speed is equals to 42. Okay. And since our original speed is 42 and the delta V is 42, our final speed becomes 0 or almost 0, very close to 0, because the question states that we need to find the maximum number of wagons the engine can actually pull. It doesn't say how many it'll take to stop the train, but how many wagons it can actually pull. So let's just look at this formula again, and let's try to find our value for W. So delta V equals K times W under root. Delta V is 42 and K is 6. Okay, let's switch up the places. 42 divided by 6. Just cut that out and we'll get around 7. To remove this under root, we're going to multiply it. We're going to do this. Apply a square on both sides. So now we only have W here. And here we have 49, which is the number of wagons. Okay. Now keep in mind this situation. We are putting the train at 0 speed when we're putting all these conditions, right? These conditions. But that's not what we really want. 49 wagons will put our train to a stop. Okay, it'll put our train at 0 kilometers per hour. But we don't really want that. We want it to keep moving. And we can't have like half of a wagon, right? We can either have 1 wagon, 2 wagon, 48 wagon, 49 wagons. So logically speaking, if 49 puts our wagon at 0 speed, it means that 49 minus 1, 48 wagons is the limit that our train can pull. Our train can pull 48 wagons before it comes to a stop. The moment you increase this to 49, it'll become 0 kilometers per hour, which is not what we want. We want it to be in 48 so that it keeps moving. And that's the answer. Don't stop at 49. Think about the problem a little and you'll be able to come to the right answer, right conclusion, which in this case is 48 wagons. Hope you learned something new. See you in the next video.